Okay, so in this video, what we're going to be looking at is we're going to be building on the concept of finding the area between two curves and seeing, well, just because we can find the difference between two curves doesn't mean that's the only thing that we're going to have to do. The last example that we looked at in the previous videos only had one boundary or one region where two functions were overlapping each other. So let's take a look at the functions here. So we kind of have, let me pick a bright color here. F of x is the cubic function, which we kind of see here. And we have a uh, quadratic function that gives us this parabola here. And I am not following that curve very well. But we see that there are two regions of overlapping areas. We have a region here and we have a region here. And we need to be able to figure out if I want to find the actual area between the two functions, I have to find the area of both of those regions. So what we were seeing previously, where we take the difference of the one function from another function, we're going to have to do that twice in this case to get the areas of both regions and then combine those two areas to get our overall accumulated area between the two pieces. Now, one thing that's really important to make sure that you get correct when you're doing a problem like this is you really need to know what are the intersections. Now, looking at the graph, I would feel pretty comfortable just saying that I have an intersection here at 0. But is this intersection here exactly at x is equal to 3, or is this one back here exactly equal at x is equal to negative 3? Because those intersection points are going to determine the boundaries of our intervals. So here and here is going to give us one area, and from there, from what looks like to be 0 to about here, this is going to give us our second area. And the intersections need to be correct. We don't just want to look at the graph and guesstimate. Now, the graph can definitely give us an idea of where the number should be, but let's not just take it for what at face value. Let's make sure. So we have our two functions, and the way that we're going to do this, finding the areas, just like we've done since system of equations in Algebra 1, is I'm going to, in this case, be able to set the two functions equal to each other, 14x plus x squared minus 2x cubed, and that will be equal to x squared minus 4x. Well, what I want to do is I want to put this in standard form. The x cubed term is the overall largest, and because it's negative on the left side of the equal sign, I'm going to move it to the right side, giving me 2x cubed, so I can kind of have it in standard form. We'll see that this x squared and this x squared are going to cancel when I move those across the equal sign, and when I move the 14x over, it'll give me a negative 18x when it combines with the negative 4 that's on the right side. Now, from here, we can factor out a greatest common factor, 2x, giving me x minus 9, or x squared minus 9, rather. And that is very much the difference of two squares. So our estimate of looking at this one here about being a negative 3 and this one here being about a positive 3, that is going to check out with the function that we have here. Because the solutions of the difference of two squares, well, let's go ahead and factor it, will be an x plus a 3 and an x minus a 3. So when I set each of those factors equal to 0, the 2x factor gives me 0 for my solution. The x plus 3 factor gives me a negative 3 for my solution, and the x minus 3 factor gives me a positive 3 for my solution. So these are the x coordinates of your intersections, or where the x coordinates of the points where the two functions intersect. And that's going to be, we want to make sure that we have those correct. We don't want to just take the graph at face value necessarily. because if we have the intervals wrong, everything else that we do from here will be wrong. So how do we actually find the areas? Well, let's again kind of keep referring to this as area 1, and let's go ahead and find that. Well, because the quadratic is essentially on top or above of the cubic function, we're going to write it off or write it out as saying here the integral will be from -3 to 0, and it is going to be the difference of the quadratic, which was, what was it, x squared minus 4x, and we're going to take the difference of the cubic function, which in this case the cubic function was 14x plus 2 or plus x squared minus 2x cubed dx. Now, inside of each parenthesis, there's really nothing to do as far as combining any like terms or anything like that. So we're going to go ahead and drop the parentheses on the quadratic piece at the beginning, and that'll just give me x squared minus 4x minus 4x. There we go. And distributing the negative in this case will give me a negative 14x minus x squared plus 2x cubed dx. Continuing by combining any like terms that we have for the definite integral from -3 to 0, you can see straight away that the x squared terms are going to cancel each other out, and the overall largest term is the 2x cubed, so I'm going to go ahead and write that first, and the -4 and the -14x will give me a -18x dx. And now at this point, now that everything has been simplified in the integrand itself, now we will take the antiderivative of each piece, and in this case I'm going to wind up with a 1/2 x to the 4th minus 9x squared from the interval of -3 to 0. And so substituting the 0 first everything is just going to simplify to be 0. So now we're going to substitute the -3. So we have 1/2 times -3 to the 4th power minus 9 times -3 squared, and see what we wind up getting. So when you go to your math here, let's see, -3 to the 4th power will be an 81. So I'll have negative on the outside, 81 over 2. -3 squared is a positive 9 times a -9 will give me a -81. And so when we distribute that negative sign, it's going to ultimately work out to be, this is equal to 81 over 2, or 40.5 as a decimal. So that is this first area here. Well, now we got to find the next area with the same process, and I encourage you to pause the video and try and figure it out before I demonstrate it. But presuming that you've done that, let's go ahead and find the second area here. And I'm going to kind of move over to the right a little bit where I have some space. So I'm going to say, now we're going to say the second overlapping area. Same idea. We're going to take the integral, and in this case, the integral is going to go from 0, 0, 0. Come on. My computer is so touchy sometimes. 0 to positive 3, but I'm glad I have it, I guess. Now in this case, when we look at the function itself, for area 2, the quadratic is what we would look at as the function that's above the cubic is above the quadratic in this case, so I'm going to kind of do what I did in part A, or to find the first area that I did in green, but now I'm going to do it in the opposite order, and I'm going to take the cubic function. Yes, I know my battery is going away. So that is going to give me 14x plus x squared. Oh, God, my computer is getting my mind discombobulated here. Plus x squared minus 2x cubed. And now we're going to subtract the quadratic, which was x squared minus 4x dx. So the cubic stuff, there's really no like terms to combine. And we'll go ahead and distribute the negatives. So we wind up with 14x plus x squared minus 2x cubed minus x squared plus 4x dx. And combine your like terms again, you're going to see the x squared terms are going to be opposites and cancel each other out. And what I'm going to be left with here will be similar to what we had before, but the x cubed term will be negative, and the x term will give me a positive 18x instead of a negative 18x. And so now we'll go ahead and perform our integration at this point. So the antiderivative of negative 2x cubed will be a negative 1/4 x to the fourth. And the antiderivative of 18x will be a 9x squared, and we're evaluating it from 0 to 3. So let's do our substitution. And we get it negative 1/4 times 3 to the fourth power, plus 9x, not x, substituting here, 3 squared. And the other bit, when I substitute 0, the 1/4 times 0 and the 9 times 0 are both 0, so all of that is just going to be a 0. And again, we're going to wind up with 3 to the fourth power multiplied by negative 1/4 will give me a negative 81/2, and then we're going to get a positive 81, and that will simplify to be a positive 81/2, or another 40.5. So the total area, is going to be the first area plus the second overlapping area, which in this case will be 40.5 plus 40.5, which gives us a total accumulation of 81. And we'll go ahead and pause with this video here. There's still some more to go in the notes, but I don't want to. I want to try to limit the length of the video so they're not incredibly long. But thanks for watching, ladies and gentlemen, and take care.